Okay, today we're going to be taking a look back at the distributive property. Hopefully it is something that everybody has seen before. Remember from once upon a time, even if you haven't ever seen it for whatever reason, it is not difficult to understand. Very simple guidelines. All you have to do is keep in mind the rules and the laws that we've already talked about over the past couple of days and simply apply one new step. Okay. The distributive property is of considerable importance in simplifying equations, which is to say if you don't do the distributive property when you need to, okay, when a problem has a setup where the distributive property would be required, if you do not do the distributive property, I can pretty much guarantee you incorrect answers. If you don't do distributive or if you do it incorrectly, it's going to backfire in a major way. Now, the distributive property in its most simple form looks like this. Okay, you have A times B plus C, which is simply to say that we have something that is multiplying times a set of parentheses. Okay, in plain English, that's what it says. We have something that is multiplying by a set of parentheses. The distributive property tells us that when this happens, you are going to have to multiply that thing that is trying to multiply by the parentheses. It needs to multiply by every single thing that is inside of the parentheses. So A times B plus C is going to end up equaling A times B plus A times C. Okay, so hopefully everybody's familiar with that. And I hope that we probably also understand that it doesn't really matter how big the stuff in the parentheses is, okay, how big the polynomial is. It can be just a monomial with one term, or a binomial with two terms, or a trinomial with three, or 100 terms inside of these parentheses. Okay, if there's something outside of the parentheses trying to multiply, then that thing is going to have to go get every term. So whatever B is, C is, D is, E, F, G, H, okay, as many terms as they want to pile in those parentheses, that value is going to have to go multiply by all of them. Okay, there's nothing really tricky to it, so let's just take a look at how it works. Here we have a situation where we've got, in the parentheses, we have a trinomial, 3 terms in our polynomial in there. Okay, but the more important fact of that is we have something that is trying to multiply by the parentheses. It's trying to multiply by the entire trinomial. Well, the distributive property guarantees us that whatever is outside of those parentheses, in this case 5, needs to multiply by every single term that is inside of the parentheses. So we're going to get a 5 times x, we're going to get a 5 times y, we're going to get a 5 times negative 3. Okay. Well, what is 5 times x? 5x, right? So numbers are going to combine with other numbers. X's are going to combine with other x's. So 5 and x, nothing really to combine with. That'll just be 5x. What's 5 times y? 5y for the same reason. And 5 times negative 3? Negative 15, right? Because with multiplication and division, if the signs are different from each other, answer's always negative. So there you go. 5x, positive 5y, negative 15. That's the distributive property, plain and simple. This is nothing new than just an extra step adding into the rules and the laws that we've looked at for the last couple of days. Okay. What about this one? What do you think it does to the problem if the thing outside the parentheses happens to come at the end? It doesn't change anything. If they want to put a term like this xp out on the right side, that's not typically the way it's written, but is it not still a value that's trying to multiply by an entire set of parentheses? Whether they put it on the left or put it on the right, it's still just a value trying to multiply times the set of parentheses. Okay, again, you don't normally see it that way. Okay, but I'm just trying to make a point to you. It doesn't matter where it is. It matters what it's trying to do. If it's trying to multiply times the parentheses, then it's going to have to distribute into the parentheses. Okay, so xp is going to have to come multiply by this positive x, and it's also going to have to come multiply by that negative 3y, and it's going to have to multiply by xz. Let's just take it one step at a time. What's this going to be? xp times x. What? XPX, or more condensed even than that. What happens if you have an X and an X trying to multiply together? What do you do with the exponents? You add them up. So we got X to the first, X to the first, it'll be X squared. So this will be an X squared and a P to the first. What about this middle term here? XP times negative 3Y. Well, numbers are trying to combine with other numbers, so we're going to end up with a negative 3. Y's are trying to combine with other Y's, so there's going to be a Y. X's are trying to combine with other X's, so there's going to be an X. P is going to try to combine with other P's. If there's nothing for them to combine with, they're simply going to just show up in the result. Okay. How about this guy right here? XP times XZ. You'll have a Z. You'll have a P. What happens here with the two X's? X squared. There you go. Okay. So this can get as weird as a problem wants it to get. Okay. But you can bet at some point in time you're going to see distributive property. And on an Algebra 1 test, I'd say you're probably going to see the distributive property no fewer than 5 times in various types of problems on your test at the end of the year. Okay, so we need to get very comfortable with this property. Now, let's look at a problem like this one. The one thing you should very easily notice about a problem like this one is it doesn't just have one set of parentheses, it has lots of sets of parentheses. And we spent some time in the fall looking at problems that had lots of sets of parentheses. Okay, do you remember what our strategies were when we had lots of sets of parentheses? What's the best place to start in the problem? You go to the part of the problem where it's buried the deepest, okay, the most sets of restrictive items, okay, which would be these little bitty, the regular parentheses all the way in here at x plus y. We would want to go there to the x plus y and simplify there kind of from the inside of the problem outward. Okay, and this is where order of operations kind of has a little bit of problems. We want to always, please excuse my dear Aunt Sally. Okay, but when you have lots of sets of parentheses and stuff like that, it may be possible for us to do, you know, my dear or Aunt Sally before we can deal with some of these other parentheses. So you go to the worst part of the problem first, and there you try to, please excuse my dear Aunt Sally. From there, you look a little bit further outward in the problem, and there you try to, please excuse my dear Aunt Sally. And then you look a little further out, and a little further out, and a little further out until you ultimately get the problem done. But at each little level that you stop at, you kind of go, please excuse my dear Aunt Sally. So let's look in deep in here in the problem. X plus y. Can those be combined? Can I take an x and add it to a y? No, those are unlike terms. They're not going to add. So I cannot, please excuse my dear Aunt Sally right there. Okay, so I'm going to look a little bit further out in the problem. What's happening just outside of these parentheses? Oh, there's a 3y. And the 3y is trying to multiply its way into our parentheses. So we need to distribute. Let's see what this is. So what is 3y times x? 3x and a y. Okay, what's 3y times y? 3y squared. There you go. Okay, if you don't know how we're getting that, you need to spend a little bit of quality time looking back at your laws of exponents from Tuesday. Okay, now, okay, so we looked a little bit outward. We found something we can do. So now we kind of stop and we go, okay, again, let me look at the worst part of the problem, which is inside of these square brackets, the 3xy plus the 3y squared. And we go, okay, I want to please excuse my dear Aunt Sally right there. Okay, so let's look at these two terms. Can these two terms be added together? You got an xy and you got a y squared. Are those like terms? They are not. Okay, remember with addition and subtraction, it's got to be the exact same set of variables, exact same exponents, or you cannot add or subtract. So, okay, please excuse my dear Aunt Sally, it's not working in there, so we're going to look a little bit further out. What do we see just outside of the square brackets? We got an x. The x is trying to multiply its way into these square brackets. So how do you do this? You got to distribute. Okay, so what's this first term going to be? x times 3xy. Exactly, 3x squared y. Okay, what about that one? X times 3y squared. You get the 3, you'll get the x, and you'll get the y squared. Since there's nothing really to join together, it just kind of all collects and makes its own term. So there's the 3x x squared y that David said we were going to have, and there's the 3x y squared. Okay, so again, we made a little step. Now we stop and we look at the most complicated part of the problem, or where it's still bound up the most, which is inside of these curly braces. And let's look in there and see if we can, please excuse my dear Aunt Sally. Okay, can I add these two terms together? Will these guys combine? What do you think? See some heads nodding yes. Okay, this is an x squared y, and this is an x y squared. Are those the same group of variables? Yes. Do they have the same exponents? X squared, x to the first. Y to the first, y squared. Is it the same exponents? It's not. Okay, so that's part of it. We can't add them up unless we have the same group of variables, which we do, but the same exponents we do not. So we cannot add these guys up. So again, we just look a little further outward and see if there's anything just outside of the curly braces we can do. And we see we got a 4 sitting out there trying to get its way into our curly braces. So once again, distributive property. I picked on a problem like this one to prove to you that, you know what, the distributive property is available anytime the problem is ready for distributive to happen. Okay, so let's see what happens here. 4 times 3xy, x squared y, well, 4 times 3, 12. And the x squared y will just be along for the ride. And then 4 times 3 xy squared. Well, again, 4 times 3, 12. And the xy squared is just along for the ride. The only last thing you can do is you can look at those two terms and say, all right, can I please excuse my dear Aunt Sally right there? But again, we run into the same sticky point. We got an x squared y, and we've got an x y squared. Those are not like terms, so they're going to stay apart from each other. Okay, so distributive property can be a pain in the hiney because it can repeat itself over and over and over again. Okay, but if that's what the problem needs, then that's what the problem needs. We'll do it anytime the problem's ready for it to be done. Okay. Let's look at one more. I think you get the idea. There's only one more point I want to be able to make before I turn you loose on your own here. So have a look at this problem, and I did provide you with a reminder or a hint, however you want to call it. Okay, and it's something we need to remember. It causes us problems on our end of year tests every year. You must remember that the signs belong to the value that follows them. For this problem, that means that the minus sign in the middle of the problem belongs to the x, and wherever the x goes, the minus sign is going to go also. It seems like every year they ask us a question that is structured just like this one, and that's why people miss it. We forget to send the negative along with the x when we distribute. Okay, so take a couple minutes. I'll give you a couple minutes of a head start. Let's see if you can't come to an answer. I'll catch up to you here on the board just in a second. Double check yourself. Your first line of your work ought to look like this one. Okay, this is exactly what they're going to do. They're going to give you a negative sign to distribute, and they're going to give you lots of negatives inside of the problem because they know that we have trouble simply keeping track of positives and negatives and things like that. Okay, so the way this happened to work out is right now you ought to be looking at all 4 of your terms are negatives. It's all the way down to an addition and subtraction problem. So from there, all you need to do is look at the problem and see if you have any like terms. Okay, when I look for like terms, I see that I have some x to the firsts right there, and I want to see if I have other x to the firsts. There are some. Okay, I also see some y to the firsts, which would want to combine with other y to the firsts, but I don't see any of those. And I have an x to the first y to the first, which would want to combine with other x to the first y to the first, but it doesn't have anybody to combine with either. Okay, so let's see, how many x to the first are there? There are -4, there are -5. How many are there? There are -9 of them. Remember, with addition and subtraction, if the signs are the same, add them up, keep the sign. Okay, there were no y's to combine with, so I'm just going to drop them down. There were no xy's to combine with, so I'm just going to drop them down. There are no other terms that are like. There's nothing else that we can do with that. Hopefully, you arrived at -9x, -4y, -xy as your answer. Okay. This is the distributive property, and as I said, it's nothing more than applying one extra little step to the rules and properties that we have talked about for the last couple of days. I've got one more example I'll put up here if anybody wants to take a shot at it. I'll be happy to come around and work with you on it. Beyond that, we're just going to go ahead and go to the worksheet. Okay, so that's it.